We continue the topic of kinematics. Now, let's assume that an object is moving along a straight line. In other words, it's a one-dimensional motion, and the relation of the object's position and the time is shown in this graph. So at time t1, the position of the object is d1, and at time t2, the position of the object is d2, and the average velocity from t1 to t2 just equals to the displacement delta d divided by the time interval delta t, and this equals the displacement delta d just equals the position d2 minus position d1, and the time interval delta t just equals time t2 minus time t1. And let's look at the graph. This horizontal dot line just represents the time interval delta t, and this vertical dot line just represents the displacement delta d. And check the graph and the formula. We can know that the average velocity from t1 to t2 just equals the slope of this dot line. This dot line is just the secant of the curve of this curve from t1 to t2. So this example shows the relation between the graph and the formula. Now look at this question. A woman leaves her house to walk her dog. They stops a few times along a straight path. They walk a distance of 1.2 kilometers east from their house in 24 minutes. In another 24 minutes, they turn around and take the same path home. Give your answers to the following questions in kilometers per hour. Question A. Determine the average speed of the woman and her dog for the entire route. And question B. Calculate the average velocity from the house to the farthest position from the house. Question C. Calculate the average velocity for the entire route. Question D. Are your answers for B and C different? Explain why or why not. So I answer this question. They walk along a straight line, so it is a one-dimensional motion. Their house, their home is here, and the farthest position is here. The distance from their house to the farthest position is 1.2 kilometers. So they walk from their home to the farthest position, and then they walk back from the farthest position to their home. The question asks the unit of the speed to be kilometers per hour. So we need to change the minutes to hours. So the 24 minutes equals to 24 over 60 hours. And this equals to 0.4 hours. And now question A. Determine the average speed of the woman and her dog for the entire route. So use the formula. The average speed equals the total distance divided by the total time interval. And this equals. So they walk from their home to the farthest position, and then they walk from the farthest position back to their home. So the total distance of the entire route is 1.2 kilometers plus 1.2 kilometers. And the total time interval is 0.4 hours plus 0.4 hours. And this equals 3 kilometers per hour. Now, question B. Calculate the average velocity from the house to the farthest position from the house. So use the formula. The average velocity equals the displacement delta d divided by the time interval delta t. And this equals from the house to the farthest position. So the displacement here is 1.2 kilometer. Then the direction is east. This is the displacement from the house to the farthest position. Also, this direction is east. And the delta t, the time interval from the house to the farthest position is 0.4 hours. So this equals 3 kilometers per hour. And the direction is east. Now question C. Still use the formula. The average velocity equals the total displacement delta d divided by the time interval delta t. And this equals, so for the entire route, they start from their home and they end at their home. So for the entire route, the total displacement is 0. So notice here, it's 0 kilometers. And the total time interval from their home to the farthest position, it's 0.4 hours. And from the farthest position to their home, they spend another 0.4 hours. So the total time interval is 0.4 hour plus 0.4 hour. And this equals 0 kilometer per hour. And now question D. Are your answers for B and C different? So they are different. The reason is that their displacements are different. One is 1.2 kilometer to east, and the other one is 0 kilometer. This question, a bus driver begins a descent down a deep hill and suddenly sees a deer about to cross the road. He applies the brakes during the bus driver's 0.32 seconds reaction time. The bus maintains a constant velocity of 27 meters per second forward. Determine the displacement of the bus during the time the driver takes to react. So from the formula of the average velocity, this equals the displacement delta d divided by the time interval delta t. From this formula, we can infer that the displacement delta d equals the average velocity multiply the time interval delta t. And in this question, the constant velocity is just the average velocity. So here, the constant velocity is 27 meters per second forward. And the time interval is 0.32 seconds. And this equals 8.64 meters forward. So the displacement of the bus is just 8.64 meters forward.